we at ipXchange have talked about creating more sustainable IoT a lot. Most of that we've done in terms of using energy harvesting. We never really thought about where that energy is being put into, and this is where Ligna Energy comes into thing, because they've created a sustainable alternative technology in terms of their supercapacitors, which are, one, non-toxic, so you can throw them away and it's not going to damage the environment, but two, really flat. So if you've got applications like asset tracking where you want to have a smart label, this is great. So yeah, check out this interview. I learned a lot, and I think you will too. Hey, it's Aaron with ipXchange. I'm here at Embedded World 2024 with John from Ligna Energy. So you guys make supercapacitors, but with a difference. So can you explain what is kind of bio supercapacitor material?
I mean, really all about pushing the boundaries when it comes to a bio-based supercapacitor. I mean, traditionally, supercapacitors do have some bio-based content, but we're just trying to push it in terms of everything that we do. If it's not bio-based, trying to find recyclable or even recycled materials. So, for example, aluminum, the metals that we need to be inside of it. Otherwise, we're just going for bio-based. So, bio-based or recyclable.
So, just to clarify things, what is bio-based?
I mean, in our case, it could, for example, be the active coal, for example, active carbon, the carbon inside. It could also be a separator, which is a cellulose separator, but it could also be the binders, and also in terms of the electrolyte, the fluid, it's actually organic. So it's all these different terminologies of bio-based, organic thrown around, but bio-based in our case, it's trying to find plant-based or
So in terms of, I'm assuming there's a sustainability angle to this.
Yes.
So can you outline what makes previous supercapacitor technology not so sustainable, and how Ligna Energy makes it more sustainable?
I mean, in our competitor's case, it could be anything from how much material that you need to use inside of it. What we're trying to do is actually pushing that as well, like making it a pouch format instead of a cylindrical form, for example. So minimizing the amount of metal that we need to use in terms of the surface. That's pushing it even further when it comes to our latest component, which is this small. So it's... But I think the inside is very much where it comes to life in terms of sustainability. I mean, we make our best in finding the materials that, as I mentioned, bio-based or organic, or also non-toxic to both humans. I mean, many of our competitors use toxic content when it comes to getting it on your fingers even, but also, of course, if it ends up in nature. So I think, we're really just trying to push that. And then in the age that we're in right now, it's also about pushing down the CO2 equivalent in terms of reporting for our clients, trying to really push that down. So I think pushing down the CO2 grams per unit, for example, that's also an important part for our customers.
Cool. So from an electronics point of view, what kind of capacities are we looking at, and what applications does that support?
Yeah, so we've done a few products in the past that didn't really fulfill the requirements of our customers, but the most popular one is this one, which is 1.2 farads. So it's for some that's a lot, for some that's very small capacitance. Our latest, this one is 50 millifarads, which is really. Both of these are trying to find the sweet spot for energy harvesting applications. So really light harvesting, radio harvesting, and for many you might need both, where you have a smaller buffer for booting up the system, for example, if it's been darkness, or just filling up that quick, the smaller capacitance quickly. But it could also be in case this could be too small. 1.2 farads is sometimes too small, that you want a bigger energy buffer, you could of course use 2. But in any case, we could, this is a demo built by ourselves. So it's 3 Swedish components. It's the invisible display, which shows temperature and CO2 warning if it's an alert of CO2 level. ipXchange, which is a Swedish roll-to-roll based light harvesting.
I think we're going to be speaking to them later on.
Yeah.
I don't know if it's today, but sometime this week.
And then we have SenseAir, which is actually a Swedish CO2 sensor inside. So it's and our supercapacitor inside.
Cool.
So this is just an indoor air quality sensor, basically. So this is one pretty common application. Then we have I just picked this up from one of our partners, which is Italy, which is it's just hanging out here. It's not really beautifully integrated, but this is an art tracker. Similar.
Do you say art tracker?
Yeah, so they put it inside of a frame for expensive pieces of art.
Oh, okay.
So really tracking so the art isn't damaged, but also sensing if someone knocks on the glass or whatever if it's touched. So this is one other application. And for the smaller component, this is just us building it ourselves. It doesn't really show exactly what it does, but it's radio harvesting, NFC harvesting instead of light. So it's just supposed to show the size of a card, which is the interest. The main interest for the smaller one is pushing inside of a card shape, which could be entrance, where you have a high security, where you need to have like a biometric sensor. So wrapping up the application is really powering sensors of different kinds, where you need where you can't put a wire in, and you need to have a wireless solution.
Cool.
Yeah.
And in terms of we always ask this question, in terms of people testing this technology, how do you go about doing that? Is it on kind of a sample basis?
We are wrapping up the production part, so it is this year we are at the end of this year we're really trying to push to get into a semi-industrial production, but right now it's sample based where you can buy it, or if you go into direct contact with us, we can supply bigger batches of the hundreds, but direct contact through the website to test it out in batches of 4. We usually send them out in batches of 4. I said that energy harvesting is one piece of it, but many also want to connect it with a battery as well. That's just the traditional
kind of like backup and
exactly. So any one who wants to play with it is very welcome to just try it out and hopefully share some interesting findings for us.
Nice. So if just one final question, if there was a perfect customer that you wanted to come approach you, what would they look like?
The customer itself could be big, could be small. At our where we are at this stage, it's just to find someone who is willing to go all the way with us, going into, because many need to do some sort of redesign, making it their system a little bit more functional for low power. Anything from the sensors to getting the energy harvesting right to really do that work, and then to really design us into their system. But then I also think, if you looked at this application, this is quite it's looking cool, but it's the typical kind of shape of this type of application. But if we're really looking what we kind of want to create, this is done by us and ipXchange. So it's their light cell, and it's our cap in the back, and then this is the radio part. And you don't need much more than this to actually create just a case for this. And make it look a bit more neat. But this is the kind of it's not a many millimeters thick, and it doesn't. It's not very big either. So I think a perfect client for us is who understands that making something thin and actually pushing the industrial design is something I would dream of, really creating a new type of sensor, for example, that really sees the value of a thin supercapacitor and not the bulky cylindrical ones or even batteries, and also who really sees the energy harvesting as something that this is groundbreaking in itself, and not going with the lazy traditional way of using a big battery and not doing the work of reshaping the system for the low power or for energy harvesting.
Cool. Well, I think that's a pretty good summary of what you guys are about, and it looks like a very good company to add to our sustainable IoT company list, because that's quite a hot topic. So yeah, come and check out Ligna Energy, and yeah, I look forward to writing this up. It's been very good to chat.
Thank you, Eamon.
Thank you for having us.
Good to meet you.
Thank you.
Where my engineers at?